Assign RS configuration to each chirality center. This is definitely a challenge problem because we can see that this molecule is really complicated. Chirality center, also called stereogenic center, chiral carbon, and so on, is a carbon that is attached to 4 different groups. So what we're going to do is we're going to find all the carbons that are attached to 4 different groups, and I'm going to teach you how to assign RS configuration in this complicated situation. Let's go ahead and let's see where we could start. Let's go ahead and start from this. So if you look at this carbon here, it is attached to hydrogen and nitrogen, and then going this way and this way is different. So this carbon is attached to 4 different groups. To assign RS configuration, we have to first give priorities to our groups from 1 to 4. 4 being the smallest, 1 being the largest, and we will look at the atomic number. So here we see hydrogen, nitrogen, carbon, and a carbon. Between hydrogen and nitrogen and a carbon, hydrogen is the smallest, so it will get number 4. Nitrogen is the biggest, has the biggest atomic number on the periodic table. That's what you're supposed to look at. If you're not sure, take a look at the periodic table to help you assign priorities. Nitrogen is bigger than carbon, and hydrogen has a bigger atomic number, so it gets number 1. Then we have to go atom by atom until we find a difference. This carbon to the left is attached to 1, 2, 3 more carbons. The carbon on the right is attached to only 1 carbon. This carbon wins, so it should get a 2, and this one should get a 3. Next, what we're going to do is we're going to connect numbers 1, 2, and 3. So we're connecting it this way. And when we connect our numbers, if it's going clockwise or to the right, this is R. And if it's going counterclockwise or to the left, this is S. I have to say that your group number 4 has to be on a dash in order for this to be true. So here my group number 4 is on a dash. I connected 1 through 3, 1, 2, 3, and I can see that it's going in a counterclockwise direction to the left. And so this configuration should be S. Let's go ahead and erase everything, put S there. Let's continue. This carbon has a hydrogen, and then we can see that it has 4 different groups as well. If you're not sure, you can go atom by atom until you find a difference. So let's assign priorities. 4 for this hydrogen. I have carbon, carbon, carbon. This carbon is attached to 1 carbon on this side, and then it has a double bond with this carbon, and anytime you see a double bond, it's the same as being attached to 2 carbons. So we can say effectively this carbon is attached to 3 carbons. This carbon is attached to 2 carbons, and this carbon is attached to 1. So this one will win. The one that's attached to 2 carbons here, going away from our carbon. This one will get a 2. And this carbon that's attached to only 1 carbon will get 3. Again, hydrogen is dashed, so we are lucky. And we're going to do 1, 2, 3, 1, 2, 3. Looks like it's going in this direction to the right. My lowest group is on a dash, so we don't need to change anything. 1, 2, 3. This is R. Let's go ahead and erase and label this as R. Let's continue. Let's go to this. Again, hydrogen is number 4, and I have oxygen, carbon, carbon. Oxygen, carbon, and carbon oxygen has the biggest atomic number, 1. This carbon is attached to 1 more carbon, and this carbon is attached to 2 other carbons. So this would win, and this would be 3. Now I connect 1, 2, 3. Again, my lowest group is on a dash. I don't need to worry about it. So when I connect my 1, 2, 3, it looks like it's going in there S direction in the counterclockwise direction to the left. So this must be S as well. Let's again erase it so we don't have to get confused. And next we're going to look at this carbon. Again, I see a hydrogen, that's number 4. This carbon here is attached to a carbon, carbon, and carbon. This carbon is attached to one carbon and an oxygen. This carbon is attached to a nitrogen and a carbon, and this carbon is attached to 2 carbons. So this will lose the most. This will be number 3. And between oxygen and nitrogen, oxygen wins. So this would be number 1. And let me just erase here. And this would be, okay, this is 4, 3, 1, and this would be 2. Again, my hydrogen is on a dash, so I'm lucky again. So let's do 1, 2, 3, 1, 2, 3, and it looks like it's going clockwise. So this should be R. Let's go ahead, erase everything, and label this as R. And we have 2 more chirality centers here. Hydrogen gets a number 4. Now, we're looking at this carbon, so it's attached to a hydrogen, a nitrogen, a carbon, and another carbon. Nitrogen is right away the biggest atomic number, so it gets number 1. This carbon is attached to 3 other carbons. This carbon is attached to only 2 carbons. So this gets a 2, and this gets a 3. Now let's connect 1 to 3. It looks like it's going in the clockwise direction. It looks like it's R. However, notice that our hydrogen is on a wedge. Our group number 4 is on a wedge. If it's on a wedge, we will switch our stereochemistry. So it looks like it's R, but because hydrogen is on a wedge, we will say the opposite. So we will say that this is S. And let's look at this final chirality center. Here, we don't see any hydrogen, so we will have a more complicated task. This chirality center is attached to carbon, 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 and a carbon. This carbon is attached to 1 carbon only. This carbon is attached to 2 carbons in a triple bond, so it's like being attached to 3 carbons. This carbon is attached to a carbon and a nitrogen, and a carbon and a nitrogen. So this one is the smallest one. It will lose because it's attached to only 1 carbon. So this I'm going to give number 4. Now, this carbon is attached to carbons only, but this carbon is attached to a nitrogen and a carbon, and this carbon is attached to a nitrogen and another carbon. So this one will lose out also. This will get number 3. Between these 2 carbons, this nitrogen is attached to a C double bond O, but this nitrogen is not attached to a C double bond O. So as we're going through these, and this is probably the most complicated case here, as we're going through these, we see nitrogen carbon, nitrogen carbon, and then this nitrogen is attached to 2 carbons. This nitrogen is also attached to 2 carbons, but it's attached also to a carbon that has a double bond, and this carbon has a double bond O. So going this way will win. I'm going to give it 1, and this will get 2. Again, I connect my 1, 2, 3, and it looks like it's going in the counterclockwise direction to the left. So it looks like it's S, but because my group 4 is on a wedge and not a dash, I have to switch it. So this is going to be R. So let's go ahead and just write the correct stereochemistry. This is Maya Lochi, and I hope you found this video helpful.